Hello, my name is Adam Edwards. This is my topic for our presentation covering topics 4.1 and 4.2. My topic is wireless LAN protocols. So to begin, the basis is the same as discussed in previous chapters, where wireless LAN consists of a system of computers that communicate wirelessly by means of radio waves. This type of network is considered as a broadcast channel, and that paired with the fact that a wireless LAN has different properties than a wired one, it leads to the creation of different MAC protocols for wireless LANs. More about wireless LANs. So, you can think of wireless LANs in an example of an office building, right? This office building would have access points across the building and are connected by some kind of wire, copper, whatever it may be. Then you have your computers, and APs are adjusted to have a distance to the broadcast, and an area within that distance is called a cell. So for example, you could have an area of about 20 feet be the broadcast distance. Every computer inside that 20 foot would be considered as a cell. Or they could have it set up to where, like, certain office rooms are set up as cells, however they want to do it. Every device in that cell shares a single channel, which is important to understand to the upcoming protocols. So, what's the problem with wireless LAN? Unlike wired systems, wireless systems cannot detect a collision while it's occurring due to how tiny the signals may be. Instead, there are acknowledgments in place to detect collision and occurrence after the fact. So if you have a collision, you're not going to know till after the collision has occurred. There's not going to be an ordinance in place to detect it during the event. Another thing, wireless LANs may not be able to send or receive frames due to the limited range inside of the cells, which is different from wired LANs, which can send and receive frames, but they have more bandwidth. So what's the first approach to the protocol? It'd be CSMA. This was talked about earlier by a previous groupmate. So basically CSMA listens for other transmission and only transmits if no one else is doing so. So if there's like nothing going on, then it'll try to transmit something. But if it hears or detects another transmission happening, then it won't do anything. So this is not a good solution, as what really matters is what is at the receiver and not the sender. So you could say, for example, in figure A of the figure below, C might try to transmit to B the same time as A since they're out of range, where, like, they both have their range. So A might try to transmit to B. C can't tell that A is transmitting to B because the only thing in range of C is B and D. So then it might also transmit to B, and in that occurrence, something's going to get lost there. Or in figure B, B might transmit to A the same time as C is trying to transmit to D, but because B and C are within each other's range and they're both transmitting, they may get confused and pause the transmission. There may be an issue with the transmission. For figure B, this actually has a name and is known as the exposed terminal problem. The second approach would be known as MACA. This stands for multiple access with collision avoidance. So what this does is it uses the sender to stimulate the receiver to output a short frame so all other stations can detect it. So what will happen is a station will send a signal letting know it's about to send, and the rest of them will be like pretty much okay, and then it'll send that signal. So in the example, A sends a request to send to B, then B will reply with a clear to send because of this. So A will send that request to B. B will then reply with a clear to send message if there are no issues there and it is okay to send. In any in range will hear the conversation. Won't send while these two are sending because of the way this is set up. But the issue with MACA still is that collision can occur. So imagine you have B and C both sending return request to sends to A. Then you're going to have a collision. But so far this is the best protocol they have came up with, and there's nothing else in the works so far. So for my question, It'd be unlike wired LANs, wireless LANs may not be able to send or receive what? And the correct answer to that would be back on the slide where it says frames, where wireless LANs may or may not be able to send or receive frames. That would be the answer to that question. And then that would be all.